Good afternoon and welcome to Global SMT and Packaging Live Show at IPC Apex Expo in sunny Anaheim. My name is Viktoria Rawinski. I'm founder and CEO of Rawinski GmbH in Germany, and today I invite you to join me for an exciting panel discussion on topic faster, smaller, wider. The quality assurance challenge of keeping pace with new trends in electronics manufacturing. Electronics engineering is developing so much faster than any other industry, and today's innovations are already history tomorrow. So we are not just talking about new components, we are also talking about new material compositions, about new flux solutions, and also solder resist materials and solder pastes. And all of this brings progress, but also new challenges in terms of quality every day, and new combinations of technologies, processes and materials have all to be managed. And I would like to discuss today with leading experts from the industry where they see the developments in their fields and how they manage to keep pace with continuous new developments in quality assurance. And my first guest is Benjamin Alves from Lackwerke Peters next to me. He's a managing director with more than 7 years of experience, and in also leadership role of a family-owned business. And he brings a wealth of expertise in the manufacturing of coatings for the electronics industry. Welcome, Benjamin.
Yes, thank you.
My next guest is Andy Bear from Panasonic Industry Electronics. So he is a business director of Panasonic Industry Electronics material business, and he and his team is responsible for printed circuit boards and semiconductor packaging materials in North America. He has more than 25 years of experience, so great, in technical marketing and business leadership. So welcome to the panel discussion, Andy.
Hey, Victoria, thank you for having me. It's a pleasure to be invited.
And my next guest is Jeff Kennedy. Jeff is a director of strategy and business development at Sestron America. He works to develop strategy and customer collaboration for projects as well as drive business development initiatives. And he has more than 30 years of experience in engineering and management, in system integrations, process developments, PWB fabrications, microelectronics packaging, and more than 20 years as global engineering director. He is also the second-term president of SMTA. So welcome, Jeff.
Thank you very much. Proud to be here.
And then let's go to our first question. Benjamin, where do you see the development trends globally and in your area of activity?
So for the electronic market at all, we see movement, especially in miniaturization, high voltage, high density boards, as well as on sustainable topics, as well as on automation and digitalization. If we talk about the material sides, the business we are working on, it's like we repeat this, we have quite an interesting trend from shifting application method for solder mask. So coming from established methods like screen printing, curtain coating, spray coating, there is a new technology by applying the solder mask with an inkjet printer on that, and there we see all the big trends also coming down, breaking on these technologies. For example, if we look at the miniaturization, maybe you can put on the slide 1. You can see that with an inkjet printer you can reach a very high precise printing and you're also able to implement new features with this technology because it's additive manufacturing basically. So if we talk about high voltages, for example, this technology enables you to print high dams. So if the traces are very close to each other, you are able to print high dams of solder mass. So you even increase the distance between the traces and then have a higher reliability on that. Coming to, for example, sustainability, this is a chance for, especially for the PCB makers, because you can save a lot of process within your PCB production, and as well as you can save a lot of materials. So you have seen that. Usually the board is fully equipped with solder mask green, but technical-wise, you can just print the traces with the solder mask, and you can save up to 95% of the material. And talking about digitalization and automation, the technology also enables you to have lot size 1. So even within one panel, you can print different designs because it's fully digital, and also including it in a line, you have a very high degree of automation.
I think it must be very important for electromobility.
Yes,
right?
For example, yeah, but you're also very flexible, so it's a good technology for high mix, low volume, where you have a lot of prototyping or small series, because you can switch it very easy.
Thank you. So, Andy, where do you see the trends globally and especially in your field of activity?
Sure, it's a good question. So primarily what we're seeing right now is demand for higher speed, lower loss materials, right? Particularly driven, here's no surprise to anybody, by the AI boom, right? This is really pushing the bleeding edge of materials performance to enable the AI, the amount of generative AI that's being produced. In addition to the driving factor around high-speed, low-loss materials, including to stack up the dielectrics, the copper, there's a need for very high layer counts in these boards, which brings us back to the point of our discussion is about quality, right? So these boards are very expensive, very high performance, so quality is paramount. Panasonic has a really strong reputation of being a high-quality supplier, a perennial benchmark in this area, so we're continuing to drive that so that the development of high-speed, low-loss materials for that market is a big driver. And then we'll talk about this a little bit more. Another separate but related topic is thinner and higher pitch counts for mobile and other applications. So the underpinning is always higher performance materials, and then depending on the end-use application, whether it's for mobile or whether it's for AI networking, has different end-use requirements that might need to be supported for that.
Great, thank you. Jeff.
Thank you. So there's three areas that I'm working in currently. One is miniaturization with the 008 40 chip caps, which are very small, very thin, low to the board, very difficult, but they're being used as we densify the electronic components on the assembly. And then the second one is around just the opposite. It's higher level integration, system in a package modules that are beyond what we've done recently in BGA technology on a level 3 assembly, but they're incorporating some die, and I'll talk a little bit about some examples of what's going on there. And the third trend, mega trend, is in the power electronics with the higher voltage, e-mobility, and charging systems for those. So those are the three areas that are really kind of driving the mega trends. And if we could bring up the first slide, I'll give an example on system in a package. These slides were just from a recent design packaging conference. You can see on this one, it's a roadmap from Yole that talks about where are we today. So We're between 70 millimeters by 70 millimeters and 100 millimeters by 100 millimeters. That's almost 4 inches square. So large surface area, very low Z height, and so those are going to present some challenges, which I summarize at the end here. Next slide, please. So these are in production by all the major CPU and GPU fabricators. You can see that we're at a sweet spot now between 70 and 75 millimeters. These are in production. Here's some examples on the left-hand side, and on the right-hand side is the next generation NVIDIA Blackwell chip, which will also incorporate some high bandwidth memory. And so the chip count is going to rise a little bit, but also the density of the interconnect at the level 2 assembly is between 50 and 100 microns. And at the level 3 assembly, we're still seeing like a BGA normal pitches, but the surface area is very large. Next slide, please. So here's some of the future technologies where we look at both the level 2 assembly going from 50 to 100 micron pitch. These would be either through a micro bump or copper pillar interconnect. And then at the board level, we're at 1 millimeter going down to 0.4 millimeter in the future, just to keep reducing the size and gain the cost efficiencies. And on the next slide, I just summarize, I won't go through all these, but these are some of the challenges associated with contract manufacturing is going to face. We see a lot of activity in the part design and the part fabrication from a silicon point of view, but there isn't a lot of activity in the consortia today talking about manufacturing challenges. So that's what we've gotten coming in front of us.
And if we are talking about manufacturing challenges, we also have some challenges on the side of quality assurance, because we develop steadily new innovative technologies, and the quality assurance is, from my point of view, is running behind and trying to catch them. So what do you think?
Yeah, so I think, the installed capital base today for contract manufacturing is used to dealing with 50 millimeters by 50 millimeters. It falls within the field of view of the pick and place machine. And as we go to 100 millimeters by 100 millimeters, they don't have that field of view now. So what are we going to design into the bottom of the part for local fiducials to be able to pick and place these things? X-ray technology is also a challenge, as well as test. Now these die, when we go to 100 millimeter by 100 millimeter, they'll have over 35,000 I/O. So that in itself is going to be a test challenge.
Wow. Andy, what's...
Yeah, I'm just going to riff. I couldn't agree more with what you're saying, and I'm going to add another log on the fire. As we go to HDI and Ultra HDI, these are new processes, new materials, new equipment, and Victoria, you're exactly right. The quality processes are lagging behind the technology, but this is the nature of things. But it's of paramount importance that it catches up as soon as possible.
But how to manage this challenge?
Well, I think we're seeing a separation, a silo effect here, where the guys that are designing the silicon and the carriers and the substrates are living in their world, and they're going to toss it over the wall to the manufacturing guys, right? And so the runway to develop the processes, how we monitor it, how we control it, how do we do the ongoing reliability testing of these things, especially in the power electronics, where they're moving to silicon carbide and gallium nitride at faster switching speeds. The failure mode isn't going to be creep, it's going to be power cycling stress. And they're in the megahertz type switching frequencies, so that localized joule heating of the die is going to cause a different kind of failure mode, which we don't even know yet, right?
Right. What's about you, Benjamin?
So for us, it's always a good question for to look at the compatibility of the materials. So we do a lot of chemistry, and if we're introducing new materials to the industry at all, there might be combination where we don't know so far, and this is something we have to look very deep into it. So, for example, for the inkjet printing, There were new machine equipment where we had to do a lot of testing. Is it compatibility? Do we have some reactions we don't know yet? So this is a big topic for us as well. But what is also important for quality is that you sometimes have new requirements. So you might know that for solar mass there are a lot of fillers inside these products, and we had to think about how we can adapt this to the inkjet, because if we talk about the nozzles, the requirements are very, very high, and we had to lower down the particle size, for example, of fillers by the factor 25. This is also quite new for the industry. We basically not talking about coating anymore. We're talking about an ink, and this is also new for our customers. So they have to look on this as well.
Okay, great, thank you. And my next question is, how can quality be guaranteed in the long term in a very geopolitically challenging time? So my keyword is global supply chains and raw materials. So Jeff, please.
Yeah, so I think, there's a lot of hotspots going on right now, and
Yes.
chaos, I'll call it, in the geopolitical environment. We see it here at the show, where people had planned on buying capital in the first half of the year, and now they're saying, we were going to wait till the second half of the year, let the dust settle and the fog clear. And so there's a lot of uncertainty in the marketplace, and certainly, navigation of the total cost of ownership. Where am I going to manufacture my product with all of these things in the spin around tariffs and regional, consumption of materials? Do they need to go into a regional supply chain model? There's a lot of questions on the table that are impacted by all of these geopolitical discussions.
Yeah, right, Andy.
Yeah, I'd like to weigh in on that a little bit. So one of the things that's very well known is the capacity constraints right now at the high end of the devices, right, of the boards and the devices. So there are supply chain constraints, and one of the things that we have to ensure, very specific to quality, is how do we increase the capacity of the raw materials, of the supplies coming in, and maintain and ensure that quality. And I don't have a pat, quick answer. The demand is there. We're just doing our very best due diligence to make sure that our current and new suppliers meet long-term quality requirements, and that is no easy challenge. By the way, those are in different regions, so there's a lot to be considered here at this point.
This is very difficult, I think, yes. Benjamin.
Yeah, it's the same question for us. But you can have a lot of strategies on that, nearshoring, multi-sourcing. We as a group have a good experience with having some core within our let me say geopolitical region. So talking about maybe 80% where you have a good supplier base, you know how the supply chain is working, but also how you can drive technical developments. And for the rest, especially for critical raw materials, which is very important for us, since the ink has 10 to 20 ingredients, we're focusing on having at least one second source from another region. But here it's good question of details, because we all know that not every geopolitical region has the full supply chain there.
And we have a lot of regulation, especially in Germany, for supply chains.
Yes, in addition to that, we have that in Europe, but we also have regulations in the US, and it's coming in Asia as well. They somehow overlap, but they somehow also have some specific requirements. We know California, for example, has that too. But this is something. If you want to act as a global player, you have to think about this as well, and
But I think every challenge also brings a chance. right?
Yeah, right. Yeah, we have seen that yeah, the new Prime Minister of Canada has been to France. I think yesterday as a kind of reaction due to the new tariff policy of US. So yeah, there might be some new chances as well.
So one door closes, maybe two new opens. Oh, we have a couple of minutes for the last and final question. So what do you think is necessary for long-term sustainable and economical electronics manufacturing, Jeff?
Yeah, so that's a good question. I wish I had the crystal ball to answer that one for you, but yeah, I think right now we're just seeing a lot of turmoil, right, and people postponing investments and trying to figure out how do they play in this new market conditions, right? So the quality challenges still remain the same no matter where you're manufacturing. We're not chasing the low labor rate anymore. You have to look at all of the things with, if it's tariffs, if it's localization of the supply chain, the logistics to move from remote geographies back to the consumer. So I think people are trying to determine their strategy as we go forward. But right now it's pretty chaotic.
Yes, right. Andy.
Yeah, so I'd like to chime in on this. So Panasonic as a corporation has its Green Impact Initiative. So Panasonic is very committed as a corporation to sustainability and longevity. And to that end, I can't disclose much here, but our division, the Panasonic Electronic Materials Division, is actively working on more sustainable alternatives or materials that can be used. We've also put solar power on our factories. So there is real commitment on the side of Panasonic to driving global sustainability for the electronics sector.
That's a very important point.
Yeah, I'd like to echo on that. I see a big push in the ESG area, sustainability area. You know, obviously people are looking for eco-friendly solutions and also looking at extending the life of the materials after the product life is gone, recycling efforts, right?
Right. Benjamin.
I think in the very long run, it's not a question of either sustainable and economic because at some point it's going hand in hand. So there is a price on the CO2. We know that. But talking about now and the next years, I think it's important to change your mind. If you said that, you already think about developing and how the footprint is. This is something I think we need to focus really. If you start developing a new product, you think about the function, but you also have to think about what is the footprint. Well, how about my CO2? How about reliability and also modularity, for example? So I think this is important, but also that we drive innovation and technology. But because then we not have small steps, but maybe can go really big step forward to that.
I know it's not a quick run, it's like a marathon we have to manage, and it's a balancing act right between the cost reduction and sustainability.
Yes, but there are good examples. So if you look, for example, on the solder mask inkjet printing, that you have a lot of savings on the economical wise, but it's also kind of new green technology where you also have a very sustainable process. So I think that can go hand in hand.
I'd like to just chime in on that one too. I think we have to resist the urge to become siloed or pigeonholed into our functions and enforce more collaboration, cross-collaboration across the whole supply chain, and that'll help us to get to the goals. Because if we just take an over-the-wall approach,
yes, right,
we're going to fail. So people need to talk about how to collaborate, how can we solve some of these challenges, and by working together.
Yeah, you've heard that idiom that for every complex problem, there's a simple and elegant solution that's invariably wrong.
Right.
It's a complex. All of us are going to have to work together. There's going to be additive manufacturing, recyclable materials, greener production. I mean, there's no simple silver bullet to this. And I will riff one more time on this, that ultimately all of us respond to consumer demand. And this is what the consumer sentiment is driving towards, as well government regulations, which are the consumers voting. And so it's incumbent on us as an industry to respond to those demands in innovative solutions. It's actually an opportunity to exhibit leadership rather than being a laggard and being forced to comply, in my opinion.
Yes, right. So what I learned today, it's not always all about quality, it's also all about communication and all about collaboration. And thank you so much for this great insights and the exciting panel discussion. So thank you for joining us today, and we will be back after a short break with our next topic.
Synchro. Join the revolution. Non-stop selective soldering. Increase UPH. Reduce maintenance. Small footprint. Contact us today for more details.